You know what?
You got one? Maybe I want to go with me.
Which one? On the back? Is this broken? No. Yeah, I'd say she's pretty cool.
Brian?
Hi, how are you?
Tom Mandel?
I'm Brian Stewart from Iowa State University.
You're the advisor?
Yeah.
You're free to talk for a few minutes?
Sure.
Or a minute? Tell me about this entry.
Well, this is the second year that we've entered the contest. So they took the lessons learned from last year's entry and really improved them quite a bit. So they went with a tricycle design. You should ask them probably. They'll be able to tell you better, but they went with a tricycle design.
Right.
And this year, a really nice part of the contest was the ability to put a manifold together. So they designed a manifold, and that really cleaned it up. And then they really tried to use tubing quite a bit to make it very, clean, nice setup.
Are you using pneumatics then in any aspect of this, or is it all hydraulics?
It's all hydraulics.
Okay.
Yep.
What have you taken away so far from this? What are you learning from this year's competition?
You really should ask them.
Okay.
Hey, Mitch.
Yeah,
You got a minute?
I do.
Hi, Mitch. I'm Tom Mandel with Hydraulics, representing Hydraulics and Pneumatics Magazine. So I'm kind of going through and getting a take on what's different about this year's entries.
Okay.
So I understand this is the second year?
Second year, yeah.
So what are you learning about this year's, what am I trying to say?
So,
what's different this year?
So basically, we took last year's bike and we studied it, saw how it worked, and it lacked in some areas. It lacked in balance. It was back heavy. Center of gravity was way off. It didn't really get off the line. It wasn't efficient enough. And so we based our bike design off of those to really build off that and try and at least compete this year. So we went the trike design with all the weight over the back axle to keep that center of gravity down low, and so it wouldn't tip backwards. We also have the reservoir on the front to kind of distribute the weight forward. We have the trike design to keep it more stable. Instead of two wheels, you have a lot more. You don't use as much energy trying to stabilize the bike when you get going. You'll see that in some of these other two-wheeled riders. Oh, wait, they come behind us. And pretty much they couldn't get off the line, and so we found out that having a bigger motor would increase our torque that we could produce on the back axle. So that's why we kept with the bigger motor, just so we could get off the line. Looking at this, they tried to change gear, but they really didn't. So we created a gearbox in there.
Right.
It's not working the way we'd like due to the forces and the components we had bought previously just weren't working, so we had to change it to a single gear.
Okay.
There's stuff definitely to be improved upon for next year, but we've definitely come a long way since last year.
What categories do you think you'll do best in?
I think we'll do really well in the sprint race. We're really easy to get off the line. The endurance race, we can either pick between a high gear and a low gear. The low gear, you just have to pedal faster, but it's a lot easier on the rider. The high gear, you have a bigger, higher top speed, but there's more torque you have to overcome. So I think we'll do well in the efficiency and endurance race. The sprint and endurance. The efficiency, I think next year we can try and get a more lightweight but bigger volume accumulator, and that'll increase our efficiency race.
Now you're a mechanical engineer, or
I'm agriculture, power machine.
Oh, okay.
We all four are.
Has hydraulics been a new exposure for you, or have you been steeped in hydraulics already?
So I think this is our first time we all dabbled with hydraulics.
Okay.
We took Brian Stewart's 413 class, and that was all about hydraulics, and that's when we got introduced to it. So we were learning everything as we were going along, but we definitely feel a lot more comfortable with hydraulics and fabrication of materials and just designing.
So you see, this has been not just a competition, but you see yourself using what you're learning from this wherever you land?
definitely.
Do you have plans after
I do,
graduation?
yeah.
What's going to happen? What are you
So
going to do?
I accepted a job with AES. It's an automation engineering company,
Okay.
and I'll be moving to Arizona.
Man, they are snapping you guys up like crazy. Employers are. That's
Yes, they
an
are.
amazing thing.
Yep. And then Dylan over there in the pink shirt, he got a position with Union Pacific.
Union Pacific. The railroad.
Yep.
How are they going to use his expertise?
Dylan.
Hi, Dylan. We're talking about you. We're talking about plans after graduation and kind of what this competition. It's been fun, but how will you apply it to where you land? So I guess you're going to be at Union Pacific, right?
Yep, at Union Pacific, a lot of their machines I'll be working with, they have a huge hydraulic components. So all their hoses and stuff, it just helps to know all that. Basically, they move a lot of weight with all their hydraulic components. So you're working with high pressures. So we have to work with a lot with safety and check valves. So I'll mostly be managing people, so I won't get a whole lot of hands-on stuff with that. But it was kind of a fun project.
But a big part of this is teamwork, right? So
Yeah.
managing a team,
Teamwork and then safety too. Union Pacific's huge on safety and teamwork, so
right?
all that plays into after college.
What about you guys?
I'm still currently searching
Okay.
for a job after college. So I've been looking at a lot of positions in the hydraulics.
Is this your first exposure to hydraulics?
Yes, this is probably the biggest introduction to hydraulics I've had so far.
Does it attract you? Can you see yourself working in this field?
Yeah, definitely. So I'm an agricultural engineer.
Okay.
So hopefully in the future I'd like to work with combines, any kind of sprayer, tractor, stuff like that. So obviously a lot of hydraulic components behind that. So this has been a huge help for me and exposing me to all the different hydraulic components.
Fantastic. And Logan?
Yes, my name's Logan. So I'm actually graduating next fall.
Okay.
Instead of this spring, but this summer I'm interning with Caterpillar, and I'm going to be working in their product development and design sector. So I mean, this project really got me a lot of exposure to just kind of like the whole design process and like just fabrication methods and different things like that, which is what I'm going to be doing a lot over the summer. A lot of product testing and everything. So this was a very beneficial project. All four of us, we really didn't have much exposure to hydraulics before this year. So just kind of this whole project really got us more interested in the hydraulics industry.
Right.
And, perhaps in future endeavors I might, revisit that in some way. But yeah, so that's what my plans are as of now.
That's fantastic. I mean, a big part of this is not just the hydraulics, but as we talked about, the team working as a team, and also supply chain.
Yeah.
Knowing when to order your components. Was that a big part of what you're doing too?
Yeah, so that was definitely a big part of this whole entire process was logistics, basically, setting things up in a way to where we could get things going bam, bam, bam. We had some troubles getting parts in as quickly as we wanted to, and that kind of impeded our process. Looking back on it, kind of really sitting down and knowing what we wanted to do a lot quicker right off the bat would have been really beneficial. And that's just kind of a learning process with any kind of project and design process for any kind of product. But yeah, I mean, this wasn't just strictly a hydraulic project. There's all kinds of different aspects within engineering that are applied to this, which is really beneficial. So.
Thank you so much,
Yeah,
guys.
thank you.
Excellent. Thank you.